Good morning, everyone, and welcome back to Generic Garage. On today's episode, we're back on the Ford Festiva. I managed to cut the rest of the frame rails out. I spent yesterday and a couple hours this morning doing that. We went through about 10 or 15 grinding discs, a bunch of body saw blades. We used the air hammer and we popped some of these welds out. I think I have everything pretty much cleaned up and where we need it to be. There might still be a little bit of cutting that needs to be done. I know I need to remove this tab and this tab over here. So we're at the point now where we're getting ready to cut the 2x3 rectangular steel so that we can put the cross tube in here. And I'm looking at what the last guy did on the Ford Shogun number 8 build, and I can see that the top of the rectangular tubing is flush with the floor in the back. So when they did the original Shogun, I believe they cut the subframe somewhere around here. And then they made sure that the top of the subframe here was level with the top of the rectangular tube. Now our bushing is about 1 inch tall, which means that we need to make sure that our tube is offset from the bottom about 1 inch above the top of the rectangular tube that was originally installed in the Shoguns. So if we space the bottom of the tube away from the floor here up about 1 inch, our bushing will sit in there. And then the top of the subframe here will be perfectly flush with the floor where the top of the tube would have been had we mounted the tube right under here. So now we're gonna grab the big piece of rectangular tubing, get our measurement left to right, cut a piece of that tubing, put it in there and tack it in place. Then we need to find the exact center of the vehicle. So the way that I figure it is we can take a measurement from left to right, mark the center in the vehicle on the tube. Then we can come down here to the subframe, and assuming that the A-arms are the exact same length, which they should be, it wouldn't make sense to have one rotate at a different rate than the other. I can grab the center of both of these bolts here, and then a midpoint will be the exact center of the subframe, which I can mark there. So finding left to right and the exact center of everything isn't a big deal. Then we need to make sure that when we mount the subframe, it's not cantered one way or the other. That way the car doesn't try to walk towards the left or towards the right. That shouldn't be bad. There's tons of reference points on the vehicle for us to look at. Then we need to make sure that it's not tilted up or down too much, and that's gonna take a little bit of work. I'm gonna have to look at some of the pictures and see how the engine sits and see how the subframe sits. But that means that we'll have the subframe at the right height. It'll be centered left to right. We'll make sure that it's not tilted, like I said. And then the last thing we have to worry about is the height of the subframe in the back here so that it's not angled up too much or angled down too much. So let's start cutting some metal. Okay, so what you just watched was me laying out the main hoop for the roll cage. Now let's talk about the tube bender for a second. We are doing everything with a 6-inch radius center line bend. That means our radius is going to reference the center of the tube. We have a 6-inch offset from the center of the tube. That means that our offset from the end of this block to the center point of that pivot on that die is 6 inches. So we need to mark all of our blocks at 6 inches away from the very start of where we want our bend to begin. Looking on here, it tells us that we have 1.05 inches per degree of bend. So for every bend that we make, and every degree in every bend, we need to multiply that number of degrees by 0.105, and that'll tell us the length of tube that we need to make that bend. So laying out our tube, you'll see I have a bunch of hatch patterns in here. I have some X's on some lines where I made some mistakes. I have my center line marked, and I have some things marked CB, which means the clamp block. I also have the start of every bend mark where it says SB, that means start bend. And then we have the end of our bend down here. So everything that's a hatch mark is gonna be a bend in our tube. Now going back to the 6-inch offset, if I wanna start my bend right here, that means the edge of my clamp block needs to be 6 inches away from the start of the bend. So if that point right there matches up with this face of the block, at 6 inches this direction, my bend will start. So because we're starting from one end of the tube and working our way through the entire tube, rather than starting at the center line of our tube and trying to work two different directions, every single one of our clamp block start points is gonna be on the left-hand side of our marks. So the left-hand side of the mark needs to be visible when we're looking at the clamp block from this side. We should see CB sticking out just a little bit on this side of the clamp block. That's gonna be true for every single one of our bends. Clamp block starts right there. That means the center point of our pivot is right here. We'll bend it 15 degrees, which will end right here. Then we'll move the clamp block down to here. Then our center point of our pivot will be here. We'll bend for 75 degrees. The bend will stop here. We're gonna go all the way down here and we're gonna continue. The clamp block starts here. The bend starts here. It ends here. Clamp block starts here. Bend starts here. Bend ends here. And by the time this is all done, we should have an exact copy of everything that we design on the computer. Make sure you do your layout. If you don't have CAD, that's perfectly fine. You can do this all on paper just to check your sanity. Here we have our measurements starting from our center line to the start of our bend is 11.74 inches. I'm gonna call that 11 3/4. That's where you would mark the start of your bend. Then you need to go back 6 inches to the left where your clamp block is gonna be. That way the center line of your radius, your bend starts right there. Keep this going all the way around. Do your multiplication for the number of degrees times the number of inches that you take up when you're doing a bend, and mark all of your points all the way around. And then once you've done that, go back and mark 6 inches from the left of the start of your bend on every single start. And you'll end up with all of your numbers for your total lengths. That'll be for half of your tube length, then multiply it by 2 for the other half of the tube, and that'll give you an overall dimension that you need for the length of tube in total. Okay, just like we discussed, CB is on the left-hand side of the block. The block's pointing upwards. Our line is right on the edge of that block, so we know that our bend is gonna start 6 inches from the edge of this block right here. Our first bend is gonna be a 15-degree bend. We want our bends to remain in the same plane, so to do that, we're gonna zero out our degree indicator, and then we're gonna clamp it on here, and that's gonna be our mark for all of our bends. If we're not planar, what you're gonna see when you look at the main hoop from the side is it's gonna look like this. The two ends of your hoop aren't gonna be quite planar. They're not gonna line up. We need them to remain perfectly in line. So whenever we move our clamp block, we need to come back down here and check to make sure that this is at 0.00 or as close to it as we can get. Okay, first attempt, not too bad. Our top bar here is pretty level within about 1/4 degree. This side is done really well. This is pretty much dead on at 75 degrees. This one's pretty much good at 90 degrees. We have it pulled for separation here right now at 43 3/8 on the center lines of the tube. But the issue that I'm running into is that this is off by a good 1/2 degree, and this one's off by about 1.5 to 2 degrees. You can see down here on the bottom, if I take this square, there's no gap at the bottom, but there's a big gap up at the top here, a good 1/4 inch to 3/8 of an inch, which means that this 15-degree bend is probably more like 16.5 or 17 degrees. If I wanted to, I could probably put a bar right across here, which is gonna end up being there anyways. The issue is that this isn't perfectly vertical. If I try to space it out more to where both of these bars are vertical, the distance between the tubes is gonna grow, and I can't have that. So I think we're gonna make another one, and we're gonna see which of the two comes out better. Like I said, I do have a couple of extra tubes. I think I said I needed 4. I have a total of 6. Let's call this one out. So now we got 5. Technically, I could do this 2 more times, and we could pick the best of 3. But I think I just overshot this bend here and maybe this one just a little bit. So I think I'm gonna take my spacing in up at the top by just a little bit, maybe 1/4 inch overall, and then sneak up on those bends a little more. And if we have to put it back in the tube bender, that'll be okay, because you can always bend a little bit more, but it's really hard to unbend things. Right now, this is under a lot of stress pulling this apart. If I let it go, everything will come back in by a good inch, 1.5 inches up at the bottom. So let's go for round number 2, see what happens. Okay, attempt number 2, a couple hours later. Took this one very slowly. Got it to like 73 degrees and 13 degrees for the 2 bends on either side, and slowly brought it down to the floor, measured it, made sure it was level, then started pulling the ends in and looking at, do I need to bend this one another degree, or this one, or this one, or this one? And anyways, I think attempt number 2 got it. We're sitting at 43 3/8, and there might be 1/2 degree off on either side, but we're gonna go ahead and drill the holes up in that rectangular tube that these will drop into. And then we'll use the strap to kind of pull it together so that it'll just fall right into those 2 holes. And we'll tack that bar in, and then we can work on the crossbar. And hopefully everything will just kind of work out. Just finished bending one of the 90s, and wouldn't you know it, the air compressor died. Okay, now to be fair, this old Craftsman my dad bought like 30 years ago, and the motor still works just fine, but I think something happened in the head unit over here. Maybe it's a valve or a check valve or a flap or something, I don't know. All of a sudden, when it was pumping up again, it just got super loud. So, yeah, great unit, lasted 30 years. We're gonna go over to Home Depot and just pick up I think a Husky. Everything else is 230 volt, and we'd have to order online, and it's about twice the price. We checked Harbor Freight, we checked Northern, a couple other places, and then checked Home Depot, and Home Depot's got a pretty good deal on a Husky about the same size, a little bit bigger, a little bit higher PSI, and better SCFM at a higher PSI than this one. So I guess it's time to upgrade after 30 years. Be right back. All right, an hour later, we're back. We got the air compressor hooked up, and I managed to bend one more tube that we're gonna need. These are the two 90s that will go off of the main hoop. That tube there and the matching one behind it over there. And those will come straight out the back. They will attach somewhere up in here, and they'll come back and then go straight down and catch these mounts here for the subframe. So what we accomplished in this video was we got the rectangular tube put in place, we got the holes drilled and the nuts welded into the tube so that now we can actually bolt in the subframe at the fronts. I got the main hoop bent up, and we got the 90-degree pieces that come off the main hoop and go down to the rear subframe mounts. So the plan with this is not to leave it like that. Obviously, this thin sheet metal is not enough to hold the rectangular tube that's gonna hold the engine, transmission, and basically support all the power for the car. So what we're gonna do is get a thick plate, maybe 3/16, quarter inch, and we're gonna cut it to fit this area here. It'll go underneath the rectangular tube, come back. I'll have a 90-degree cutout in the corner of that plate, and it'll encapsulate this entire tube here. And then we'll weld everything everywhere that we can on both sides, and that should be strong enough to hold it. So yeah, we're not just gonna leave it like this. We're gonna have a plate up there, a plate back there, maybe some plates some other places to where we can tie the whole tube frame into the vehicle. Obviously, everything's just kind of tacked in place right now, and we still have a lot more work to do. It is a little after 7 o'clock on Sunday. I have about an hour drive to get home. So I'm gonna go ahead and call this video done, and on the next episode, we'll just get right back into working on the rest of the roll cage, subframe, all of that. But I do wanna say thank you to everybody who's continuing to watch these videos and everybody who's subscribed. I really appreciate it, and I can't thank you enough. I think YouTube actually changed their subscriber requirements down to 500, but you still need something like 3,000 hours of video watched in the last 365 days. So if you've watched till the end of the episode, I really appreciate it. Tell your friends, if you know anybody that likes cars and you told them about a Shogun and they don't know what it is, maybe show them these videos. If you guys have any questions you'd like answered, please ask below. I'm more than happy to sit here and chat back and forth with y'all. If you have advice or any comments to give, any feedback at all, please just leave it down below. Also, if you wouldn't mind, if you haven't done so already, please hit that subscribe button. Again, thank you if you made it this far. I'll see you guys next week on the next episode, and until then, y'all stay safe, have a great week. Bye.